Bismillahirrahmanirrahim. Assalamu alaikum dear students and viewers. Welcome to my YouTube channel DigiLearnersPoint. In today's video, we are going to solve the question number 4 of assignment number 2, which is related to the subject business statistics, which has subject code 1430, and it is related to Atom 2022 of AIOU examination system. The question number 4 is here: are good grades in college important for earning a good salary? A business statistics student has a random sample of starting salaries and college grade point averages for some recently graduated friends of him. The data is below. Follow. Starting salary 36 and its corresponding GPA is 4.0 and 33.0, 33.5. 24 salary is 2.0, 27, 2.0. Look at this. For the same GPA 3.0, 3.0, we have different slab of salary which is starting from 30 to 27, and look at the remaining 33, 3.5, and here also 30,000 for 3.5, 2.5, 20.2.5, 27, and 27 also corresponding to the GPA 3.0. So the first requirement is to plot these data. Then the second requirement, calculate coefficient of determination. Plot the estimating cushion on the scatter plot of part A, and the slope is significantly different from the 0 at 5% level of significance. So let's move to the solution that I have already prepared in Excel sheet. Here is the solution. So and these are the data given in the questions. I just take it from that question and put it into the cells here. So the first column is GPA and the other column is starting salary. So as you notice in the question that the salary depends on the GPA. It means independent variable is GPA and dependent variable is starting salary. So keep in your mind one thing, that you always keep your independent variable at first position and all the dependent variable uh, all the and the dependent variable on the right side of the independent variable. This is the pattern of placing variables in Excel sheet. So we are going to now plot the data as per the first requirement. Select both these two tables and then go to the insert. After insert, go to the chart, and here you notice that here is the insert scatters diagram. I'm click on that one and pick the first one, scatter. As you click on this one, you will see that chart is diagram is appear in front of you. Just drag it into the its concerned place here. After that, plot this data. Why we are going to choose the scatter diagram? Because scatter diagram is the one that helps you to identify the relationship between the two variables or multiple variables. Look at this. Here you can observe that the dots, one dot is a pair of the x values and the y values, x coordinates and y coordinates. So I'm going to tell you that if let's suppose our first point is 436. So let's come here. Here is the 4 and here is the 4, and 36 is somewhere here. So this point is the actually has two components, x and y. X is 4 and y is value is 36. So two coordinates, x and y. So we have plotted successfully the data depending data based on independent and dependent variable. Let's make some study of this graph by assigning some value to it. Click on this plus sign. After that, you look at this x-axis. So click on this one. As you click on this one, go to this one and you will get primary horizontal. So you primary horizontal, where is that gone? Sorry, again already is available, but I make this one. I will write it here, GPA scores, and then I am going to be and if you want to make this color different, you can make this. So I'm going to be write this here. What starting salary? Starting salary. So after this one, I'm going to be uh, change the title of the this graph, or I'm going to written here first Control A and just go here and write here uh, GPA versus starting salary. Okay. Now I have cosmeted our graph some to some extent. So our independent variable on GPA on x-axis GPA score. GPA, I think this is GPA. So please correct, make it correct. And on the vertical axis there is a starting salary. Now the second point is to be determined coefficient determination. Coefficient determination, if the equation is linear equation based on two variable or one variable in case of independent variable, so our correlation and the coefficient determination is similar or same. But in case of uh, multiple regression equation where we have more than two or three independent variable, so the case is different. So coefficient of determinant is different from the correlation coefficient. But here, the case, is the first that I have discussed with you, means correlation coefficient and coefficient determination are same because it's a single variable coefficient in terms of independent variable. To determine the coefficient of determination, we make an equation salary is equal to B grade. B grades are GPA plus a constant plus any constant. I didn't written here. I just going to be right here constant. So I have written this equation y is equal to bx plus c. Another form of this equation to be presented is like y is equal to mx plus c. Whichever the notation you want to be used, you can use, but keep in mind that the power of the independent variable is 1 in this case. So we need to be determined here b is the slope of the line and slope of the regression line. So b by x means y is dependent and x independent. B by x means y depends on x. So here is the formula for b by x, slope of the regression coefficient, n into summation x y minus summation x into summation y divided by n into summation x square minus summation x whole square. So what we need summation x, summation y, and summation x y. These already variable summation x, summation y. What we need this summation x y and summation x whole square. So let's back to the our table. Here I am going to determine x y, multiply this 4 into 36 means I assign x notation to the GPA as an independent variable and y number to the starting salary. So x by 144, I am going to multiply 4 into 36. So I am going to use a formula here C30 and just I am going to drag this down to get the all concerning values of the xy column. After that I am going to be add this one. So summation of x y is equal to 703 point x. Now the second component that we need to determine the value of the b by 1x is x square. So just taking the square of this like this, b3, this is the sign which is used in excel for power 2 means square. So just you write this formula and drag it down 75. For this now it is for the requirement of 2 function is enough here. So I am going to be put two cells here, numerator and denominator separately to find the b by x easily. Then I am going to use we put all the values of summation x plus summation x summation y and I will get 156. If I will click on this one, you will find this 8 into d11 minus c11 into b11. This is the formula. Now denominator is n summation x square minus summation x whole square. Look at this, 8 into 75 minus 24 into 24. Now by substituting the values into the formula b by x, I will get the value of b. I am going to be color it with background yellow to identify to make it separable from the others. Now the second term that I need to know is the a. Here a is a constant. So how could I determine this? The formula for a is equal to y bar minus bx bar. So mean is 3 and y bar is equal to 28.5. So I am going to put the formulas here. Y bar is equal to 28.5 minus C3 is C37 means and b values is 6.5 into this 3. So I will get this value 9.0, which is a value of constant a. So lastly, putting these values of b and a, we will get the estimated equation of our regression as the population equation y hat is equal to 9 plus 6.5x. So next we are going to be determine standard error of estimate, which is equal to square root e raised power 2 divided by minus 2, and first e is equal to y minus y hat. Y is actual observation and y hat is going to be obtained by putting the values of x into this. Let's move back to the table. I am going to show you this. Look at this. This is the question that we have calculated. Now put all values of x one by one into this question. You will get the value of y hat. Now I told you that e is equal to y minus y hat. So I will get this value of this column, and please be noted one thing, that the sum of the this e is equal to 0. Basically e is the deviation of y is the deviation of the estimated values from the actual value, and one important fact is that either deviation from above the line, this estimated line, or below this estimated line, if you are going to sum up, is equal to 0. Get the square root of the square of this column, so we will get 35.250. Leave this one. So come back to the solution. So I am going to be determine this square root 1.5 1209006, and this is the formula that I am going to use. 1 minus I11 divided by K11. Let's back to the I11 and K11. Yes, we need this. Sorry, before I told you, ignore this one. Just focus on this one. Y minus y bar divided by y minus y bar whole square. So we need this one. I am going to be this I11 divided by K11. So I am going to be this is I11 35.25 divided by 162. Resultant will be subtract from the 1, so we will get the value of r square. So these are the coefficient determination. And please, I am going to make a request here that if you found some mistake in calculation, please must be mentioned in the comment section, or if you want to get some mistakes regarding the calculation and formula, must highlight in the comment section, so it will be beneficial for all of us. Now come to the C part of this question. Plot the symmetry equation on the scatter plot of part A. So how can you do that? I'm going back to this graph. I'm just click on this any button on dot and right click. After that right click, you will see here at trend line. As you click on trend line, format trend line box is open in front of you. You just click the linear. After that, you are going to scroll down here and here mention it, display equation on chart, and display r squared value, means the coefficient of determination. So this is the equation I am going to tell you here. So after that, the part this equation will be appear here like this. This one, this dotted line is your required estimated equation line. Here I done into the different colors with different length. So come back to the question number part 4. Test the slope is significantly different from 0 at 5% level depth, significance. This is beta. Beta means capital B, and B is representing the population. So we are going to testing the population on the basis of this sample. S naught is equal to beta is equal to 0, and beta is not equal. This use exclamation mark is equal to 0, or you can write also this two symbol is also means that it is not equal. So level of significance 0.05, and step 3 is the critical value acceptance region. We are going to determine this. So we will go to the table. From table you will get this value 2.4, this 2.145, and I am going to use the degree of freedom. This is plus minus 1 because this is a two-tailed test, so I am going to use plus minus 1. Preferable me this 2.145 because I am using this degree of freedom, and 1 plus and 2 minus 2. So come to the T observed means T calculated. T is equal to B minus B divided by SB, or SB is equal to, here is the formula of SB is equal to SC divided by square root function x square minus n x bar square. So I am going to be put values into this, and the first formula is for SC, so I am going to be using this formula to find the value of SC, and then later I am going to use this value to find the value of SP. This is the formula SC divided by summation x square minus n x bar whole square. T increase, and after that I am find the value of this 4.644. So look at this, and this value is positive and lies outside the right tail of the this distribution. It means that we are not able to accept the uh, H not null hypothesis, and it means that our yes, the slope is significantly different uh, from the 0 at 5% level of significance. I hope you will enjoy this uh, solution. One last thing that I am going to show you that how to make picture here. Please be patient here. It is for your benefit. So I am going to be use here. First I am going to click this one. Okay. Then just draw a line here. Click upon one straight line on here. Copy it to lines. Why I am copying this? This is just a rough thing. And 2 point minus 2.14145 is lies here, and positive is lies here, and this is if the value lies between these two limits, then it will be accepted, otherwise it will be rejected. So 4.644 is lies outside this tail, so it means that we are not able to accept the null hypothesis, and we believe that we will go with the alternative hypothesis that uh, B is significantly different from the 0. It means slope of the equation is significantly different from the 0 at 5% level of significance. This is our conclusion. I hope you will enjoy this session. If you have any question and query, ask in the comment section. If you want to add something more from your side, drop your suggestion and advices with logical arguments. Thanks for watching. Assalamu alaikum.